Okay, if you are new to this channel, please try to subscribe and please press that like and try to share, please. Now today we want to talk integrations. Like we've been treating differentiation for a long time, and we know that differentiations, when you take a particular function, you are differentiating it. It will tend to, let's say you differentiate it again. It will get to a particular point whereby it will tend to zero, to become zero. But when you are integrating something, it has the ability to be increasing and to be increasing. That is the integration. That means integration is anti-derivations. That means it's the opposite of differentiation. Now, we have some standard integral form. There are things we have to know on integration. There are standards. Number one, how to differentiate. If I am given this, that is integral of x squared dx. How will I differentiate? How will I integrate it? Now, this symbol is a symbol of integrations. So what do I do is that the formula of integration is when you have something like this, xn, so you add 1 to that power all over whatever you have here, you write it down as your denominator plus c. This c is arbitrary constant. Arbitrary constant. That means this power, add 1 to it, and whatever you see here, bring it down plus c, which is arbitrary constant. Now we are given this now. So if I want to integrate this, what will I do? That will be x squared plus 1 all over 2 plus 1 plus arbitrary constant. That is x raised to power 3 all over 3 plus c. Or some people use k. Anyone. That is how to integrate. That is the first standard integral form. Now, another standard integral form. You have integral of sine x dx. Integral of sine x dx. That's another standard integral. As we all know that I told you that it is one and opposite. We all know that differentiation of derivative of sine x is actually cos x. Don't forget that sine x is cos x because it is one and opposite. That means integrations of cos x dx. That means if they integrate cos x, but it is one and opposite, it will give them sine x plus c. Integral of cos x, it is sine x, because do not forget that differentiation of sine x is cos x. Differentiation of sine x is cos x. So if I integrate cos x, it will give me back sine x. It is a one and opposite. That's why integration of cos x is sine x plus c. Don't forget. Now, if differentiation of sine x is cos x, now, as you all know, what is now differentiation of cos x? Differentiation of cos x. You all know that differentiation of cos x is minus sine x. When you differentiate cos x, it gives us minus sine x. That means integral of minus sine x dx. Integration of minus sine x dx will give me cos x. Integration of minus sine x will give me cos x. Now here, I asked for integration of ordinary sine x. And we know that integration of minus sine x will give me cos x. So integration of ordinary sine x will give me minus cos x plus c. So when you know the differentiation of particular one, the opposite of it, it is your integration. Now, another standard integral form. When you have integration of tan x, integral of tan x dx. Now, as you all know, that differentiation of tan x, it is sec square x. That differentiation of tan x is sec square x. That means integrations of sec square x dx. We all know that differentiation of tan x is sec square x. That means integration of sec square x, it will give me tan x plus c, arbitrary constant. That means integration of sec square x will give me tan x. So that means plus c. Now, what is now integration of sec x? Now, we all know that in our differentiation of sec x, remember differentiation of sec x, remember we are differentiating sec x is actually 1 all over cos x, which is u all over v. And we know that v du dx minus u dv dx all over v squared. And if this is our v cos x, when you differentiate u, what's u? Differentiation of u, that is 0. Minus, what is u? 1. Differentiation of v cos x, that is minus sine x, all over, what is v? V is cos square, that is cos square x. This one has come to 0. Minus and minus, that's plus, that is sine x, all over cos square x. That means you can say sine x over cos x times 1 all over cos x. As you can see, this sine x all over cos x all over cos square x. So this one is going to give us sine all over cos, that is tan x, and 1 all over cos x is sec x. Now, if differentiation of sec x is tan x sec x, differentiation of so what is now integration? Integration of tan x sec x, integration of tan x sec x is going to give me like opposite back. It's going to give me sec x. Just what an opposite. Sec x plus c. Integration of tan x sec x is to give me sec x plus arbitrary constant. Now let's take a look at another one. What about cosec x? How about cosec x? Cosec x. Cosec x. We all know that differentiation of cosec x is what? Cosec x, as we all know that cosec x is 1 all over sine x, which is u all over v. This is u and this is v. And our formula is v du dx minus u dv dx all over v squared for differentiation of cosec x. And what's our v? Our v is sine x. What is u? U is 1. Differentiation of 1. That is 0. Minus, what is u? Our u is 1. Differentiation of v, that is sine x, that's cos x. All over, what is v? Sine x, that is sine square x. Now, this one has come to 0. Now, this is minus cos x plus minus cos x all over sine square x. So that means you can say minus 1 all over sine x times cos x all over sine x. All over sine x. Because this is that minus over sine x and the cos x all over because they are sine square x. And what would that one give us? That one will actually give us 1 over sine x, that is cosec minus cosec x minus cosec x, cos x all over sine x, that is cot x. That's the inverse of tan x, that is cos x all over sine x. That means differentiation of cosec x give us minus cosec x cot x minus cosec x cot x. That means integration of minus cosec x cot x is going to give us cosec x plus c. It's going to give us cosec x plus c. Now, let's take a look at another one. What is derivative of exponential x? Exponential x is still exponential x. Do not forget that derivative of exponential x is exponential x. That means I ask you that what is now integration of exponential x? The x. So that means it's going to give me the x, don't forget. It's going to give me, since this one is actually this one back. So integration of exponential x dx is going to give me exponential x plus c. That will be the integration of exponential x. Now, let's take a look at ln x. You all know that differentiation of ln x, it is actually 1 all over x. 1 all over x. That means if I integrate 1 all over x, the x, it is going to give me ln x plus c. That means integration of this will give me this back. 1 all over x. Integration of ln x plus c will give me 1 all over x plus c. So it is vice versa. Vice versa. Now let's take a look at some questions. That is some standard integral form. So let's take a look at some questions. Example. Number 1, integrate x raised to power 7 plus 1 dx. Let's be taking it one after the other. My aim is for us to get this thing, to get the basic very well. So that's why we have to take our time and learn this thing. Now, when we are having something like this, integration of x raised to power 7 plus 1 dx, actually you can integrate it separately. Integration of x raised to power 7 dx plus integration of 1 dx. You use this integration to open the bracket, and the x will come true. According to the formula, when you integrate this, that will be x raised to power 7 plus 1 all over 7 plus 1. Don't forget, plus, what is integration of 1? Integration of 1 is x. Do not forget that if it is differentiation of 1 is 0. But integration of 1 is actually x. So that means x raised to power 8 all over 8 plus x. And don't forget the arbitrary constant plus c. So that is for that. Number 1, number 2. Number 2, are given, we should find integration of root x dx. Root x dx. How do we solve this? Integration of root x dx, that will be, root x can also be turned to x raised to power 1 over 2 dx. So just say x plus 1 all over 1 all over 2 plus 1 all over 1. I told us that whatever you see here, you bring it down as your denominator. So that one will give us x, the LCM here is 2. 2 into 1 times 1, that is 1. And 2 in 1, 2 times 1, that is 2. All over 1 plus 2 over 2. That is x raised to what? 3 over 2, all over 3, all over 2. Now, when you have something like this, what really goes to? You know, when you have something like this, we have x raised to power 3 over 2. This line is divided by 3 over 2. And what does that mean? To turn to x raised to power 3 over 2 times, it becomes 2 all over 3. So that one will give us 2 multiplied by this, and is 2x raised to power 3 all over 2 all over 3 plus c, arbitrary constant. That is that about the integration of x. Now, let's see. Integral of integration of the x all over cube root of x squared. When you are given something like this, what do you do about it? So that means integral of 1, it means 1 all over 3 cube root is not 3, it is cube root x squared dx. You just move this dx to the back. So what does that mean? Now, a lot of indices, this thing can be written as 3 into s squared all over 3, as we all know. So this 3 will come back. So when we have something like this, I think we can integrate it. So that will be, I can bring it up. If I bring it up, so it will become x raised to power minus 2 all over 3 dx. So I can now integrate it. If I want to integrate it, that will be x raised to power minus 2 all over 3 plus 1 all over 1 all over minus 2 all over 3 plus 1 all over 1. So that means if you collect your FCM here, our FCM is going to be 3. Now 3 in 3, 1. 1 times minus 2. Minus 2 plus 1 all over 1 plus 3 in 1, that is 3. 3 times 1, that is 3. All over minus 2 plus 3 all over 3. That will be x minus 2 plus 3, that is 1. 1 all over 3. Also the same thing as 1 all over 3. Like I told us earlier, when we have such it's going to be in this form at x raised to power 1 all over 3 divided by 1 all over 3. As x raised to power 1 all over 3 multiplied by this one will go, 3 over 1 is 2. That means it's 3x raised to power 1 all over 3 plus c. Plus c. That is, now let's take a look at how we like us to have a good understanding about the beginning aspect of this before we start doing some techniques. Let's take a look at this. If you are given integral of x plus 1 all over x dx, how do you solve this? It's like you see the same thing. That means integral of x dx, just use this one to open the bracket, plus integral of 1 all over x dx. So if you integrate this x, so that means it's going to give me, it has a power of 1. 1 plus 1 all over 1 plus 1. Plus, what is integration of 1 over x? That is ln x. In x, that means x raised to power 2 all over 2 plus ln x plus c. plus c. As simple as that. Now let's take a look at lastly under this aspect of integrations. If you are given something like this integration of open bracket s cubed minus 3s squared plus 2x plus 5, close the bracket, dx all over x. All over x. What will you do? I can just say, if you have something like this, just distribute this x for all of them. That will be s cubed all over x minus 3s squared all over x plus 2x all over x plus 5 all over x dx. That means we are having so this one remains s squared minus, if this one comes with this, it remains 3x plus it remains 2 plus 5 all over x. Now if I integrate s squared, so that will be x no plus 1, that is 3 all over 3 minus, if I integrate 3x, what will it give me? So I'm going to have 3x, I'm going to have 3x, there is a 1 here, plus 1 all over 1 plus 1. That is 3x is to the power 2 all over 2. That is minus 3x raised to the power 2 all over 2. Now if I integrate 2, what will 2 give me? Integration of 2, that will be 2x. That is going to give me 2x. That is plus 2x. Now plus, what is that integration of 5 all over x? As you all know that we can write it as 5 times 1 all over x. So 5 times 1 over x, and we all know that 1 over x, integration of 1 over x is ln x. So that means this can be 5 ln x plus 5 ln x. Everything plus c. Plus c. Now let's go to some techniques of, okay, they are having something like this in integration. Now you may be given some brackets, like having some brackets, and I ask you to integrate. What do you do? Just expand the brackets and you integrate them one after the other. Look at this aspect. We are given integration of exponential x minus sec x tan x dx. Exponential x sec x tan x dx. Now, what is integration of? You do integration of exponential x minus integration of sec x, okay, exponential x dx minus sec x tan x dx. I use integration to open the bracket. And I told us earlier on that integration of exponential x is t exponential x minus, what is the integration of sec x tan x? Which of them give us sec x tan x the other time? That is sec x. But I told you the differentiation of sec x, if you check the other examples I've done, differentiation of sec x is the one that gives us this. Actually, I don't cram those things. I don't use to cram it. If I have it, I'll check it again. I can quickly do it again. Differentiation of sec x gives us sec x tan x. So that means integration of sec x tan x will actually give us sec x. That means exponential x minus sec x, plus c. Plus c. Plus c. Now, okay, Let's see this. Integration of sine x plus 1 all over x dx. Sine x plus 1 over x dx. You can separate like integral of sine x plus, that is integral of sine x dx plus integral of 1 all over x dx. Now, what is integration of sine x? I told you that differentiation of sine x, or differentiation of sine x, it is for sine x, it is actually cos x. Now, that means integration of cos x will give me back sine x. Differentiation of sine x give me cos x. That means integration of cos x will actually give me minus sine x. It is what an opposite. If differentiation of sine x give me cos x, differentiation of sine x give me cos x, that means integration of sine x will give me minus cos x. Integration of sine x will give me minus cos x. Minus cos x plus integration of 1 over x will give me ln x plus c. Please don't forget, differentiation of sine x, it is cos x, while integrations of sine x, it is minus cos x. You should not forget. Okay? We have another aspect of integral of calculus called by substitution. By substitution. By substitution. So if you are having example like this, integral of 2x plus 3 raised to power 5 dx. How do you solve this? By substitution. So we represent whatever we have by u, like we used to do chain rule. That means u equals to 2x plus 3. Don't forget. And what is the major thing? We want to find the value for dx. That is the major reason, because this is not differentiation actually. We want to get the value for dx. And let's wait. I'm going to differentiate du dx. Du dx. What's 2x plus 3? Normal dimension of 2x plus 3, that will be 2. You know, 3 is 0, dimension of 2x is 2. That means du equals to 2 dx. Don't forget, I'm looking for dx. That will be all over 2 over 2. That means dx equals to du all over 2. I've gotten my dx. My dx equals to du all over 2. That means I must say integral. This one I represent as u. That means u raised to power 5 multiplied by my ds is du all over 2. Du all over 2. What will I do? So I can bring this 1 all over 2 out here. That means 1 all over 2 integral of u raised to power 5 du. So if I integrate, I cannot integrate it. That means 1 all over 2. If I integrate u raised to power, that u raised to power 5 plus 1 all over 5 plus 1. You will neglect this du. Now, what would that one give us? It's going to give us 1 all over 2 u raised to power 6 all over 6 plus c. That means 1 times 2, that is u raised to power 6. All 2 times 6, that is 12 plus c. And don't leave it like this. Substitute for that u. Just write the value of u back. So that will give us. And what is the value of u? I will use 2x plus 3. That means 2x plus 3 raised to power 6 plus c all over 12. Okay, that is why substitution. Now another one under this substitution. If you are given integral of exponential raised to power minus 5x plus 2 dx. Actually, I'll stop here today. After solving this, we have to meet for the next class in other integrations, and you don't need to miss it because we still have many techniques to do. Now, what do we do here? We represent this by u. U equals to minus 5x plus 2. Don't forget that we want to get the x. That's our reason of doing that. Find du dx. If you differentiate this, that will give you minus 5. Because differentiation of 2 is 0. Minus 5x is minus 5. Du equals to minus 5 dx. Don't forget, I'm looking for dx. That's over minus 5. Over minus 5. That means dx equals to du all over minus 5. So I've known my x to be du all over minus 5. What will I do? I'll just say, and if the question is integral of exponential, you know that one has been represented as u multiply by, and what's my dx now? Du over minus 5. I can just bring this one outside. So I'll say 1 minus 1 all over 5 exponential u du. And what is exponential x? I told that integral of exponential x is still exponential x. That means integral of exponential u also is exponential u. That means it will be minus 1 all over 5, because this one is still the same. Exponential u plus c. That means we substitute for the value of u. Minus 1 all over 5 exponential. And what is our u? Our u is minus 5x plus 2. Minus 5x plus 2 plus c. So I'm going to stop here for today. So guys, under this introduction that we did, we're still going to do the upper limit and the lower limit, how to do those ones. So in our next class, please do not miss out as you are progressing under this integration step by step learning. Thank you. Make sure you subscribe.